Hello students, welcome again in the another session. Previous session of polynomials part 1, we have studied all the basic concepts regarding polynomials. You can watch that video. I will provide the link in the description below. In today's session, we are going to solve some examples based on those concepts. Our next point is the division of polynomials. In the previous session, we have studied how to divide two polynomials by the traditional method. Our today's point is division of polynomials by synthetic division method. So for that we are going to solve one example. The question is, divide each of the following polynomials by synthetic division method and write quotient and the remainder. The first problem given here is 2m square minus 3m plus 10 divided by m minus 5. So we have to solve this problem by using synthetic division method. So to use the synthetic division method, first we have to convert the polynomial which is to be divided in coefficient form. Before that, we must check whether the given polynomial is in the standard form or not. If it is not in the standard form, we have to write it in standard form and then in the coefficient form. So first of all, let us name the given polynomial which we have to be divided. So let p of m is equal to 2m square minus 3m plus 10. Now we'll write the coefficient form of this polynomial. While writing the coefficient form of any polynomial, we just write the coefficient of each term in the polynomial into bracket. So the first term is 2m square, its coefficient is 2, so we'll write firstly 2. Then second term is minus 3m, its coefficient is minus 3, and the constant term is 10. So 2 minus 3, 10 is the coefficient form of given polynomial. Now the second polynomial by which we have to divide is m minus 5. So again, for the synthetic division, we must equate this polynomial to 0, that is m minus 5 is equal to 0. That is, if we transfer 5 to the right hand side, we will get m is equal to 5. So in the synthetic division method, we have to divide the coefficient form of a polynomial by 5. So for that, we have to draw this symbol in which we have to use the synthetic division method. So the coefficient form is 2 minus 3, 10. So we should write those coefficients 2, minus 3 and 10. And we have to divide this by 5. So we'll write here 5. Now to start for a division, firstly we'll take 2 as it is. Then we'll do the product of 2 and 5, that is 5 2s are 10. Now we'll do the addition of these two, minus 3 plus 10. The answer will be plus 7. Again take a product of 7 and 5. 7 5s are 35. And again we will add these two, 10 plus 35, that's 45. Now in this division, the last term is the remainder. And the other two terms, those are the coefficient form of our quotient. So the coefficient form of quotient is just 2 and 7. Now we have to convert this in standard form. So here 7 is the constant term and 2 will be the coefficient of the term m. So we have to convert this in quotient form. Therefore, we have to write the quotient by using variable m, that is 2 into m. 2 is the coefficient of term m, so 2m plus 7. So the quotient is 2m plus 7 and the remainder is 45. So this is how we can divide any polynomial by a synthetic division method. We will solve another example of the same type. polynomial is 2x raised to 4 plus 3x cube plus 4x minus 2x square, and we have to divide this polynomial by x plus 3. So first of all we have to write the given polynomial in standard form. As we know, in standard form we have to write all the terms in the polynomial in the descending order of power of the variable, that is x. So the highest power amongst all these terms is 4. That's why we have to take the first term 2x raised to 4, then plus 3x cube, then square term is there minus 2x square, then plus 4x, and in this polynomial constant term is missing. That's why instead of that we can take 0. So this is the standard form of the polynomial. We'll give name p of x for that polynomial, that is 2x raised to 4 plus 3x cube minus 2x square plus 4x plus 0. Now to divide this by a synthetic division method, we have to write the given polynomial in the coefficient form. So the coefficient form is, we have to collect all the coefficients from the terms, that is 2, 3, the coefficient of third term is minus 2, 4, and last is the constant term, that's 0. So this is the coefficient form of the given polynomial. We have to divide this polynomial by x plus 3. So we'll equate that to 0. So by having that, we will have x is equal to minus 3 as plus 3 going to the right hand side. So we have to divide these coefficients by minus 3. We will have this symbol. Inside that we have to write all the coefficients, that is 2, 3, minus 2, 4 and 0, and we have to divide this by minus 3. Now start with the division. We'll take 2 as it is. 2 into minus 3, it will be minus 6. Now we should add these two. 3 minus 6, it is minus 3. Again have a product of minus 3 and minus 3. So minus 3 into minus 3, it will be plus 9. Minus 2 plus 9, answer will be 7. Again take a product of 7 and minus 3, that is minus 21. We'll do the addition of these two, 4 and minus 21, that is minus 17. Again have the product of minus 17 and minus 3, that is plus 51. We should add these two. 0 plus 51 is 51. So in this product, the last term is always a remainder. So we'll get the remainder, and to find the quotient we have to write the coefficient form of the remaining terms. That is, the coefficients of the remaining terms are 2, minus 3, 7 and 17. So you should write that in bracket 2, minus 3, 7 and minus 17. So this is the coefficient form of the quotient. We have to convert it in the standard form of a quotient. So to convert this in the standard form, as there are 4 terms in the coefficient form of a quotient, the highest power of the variable x will be 3. The first term of a quotient will be 2x cube minus 3 into x square. Now we have to write all the terms in the descending order of the power of x, plus 7 into x, and last term is the constant term, that is minus 17. So here the quotient is 2x cube minus 3x square plus 7x minus 17. So by dividing the polynomial 2x raised to 4 plus 3x cube plus 4x minus 2x square by x plus 3, we will get the quotient as 2x cube minus 3x square plus 7x minus 17 and remainder as 51. Let's have the next concept, that is value of a polynomial. Suppose there is a polynomial given p of x in the variable x, and if we have to find the value of that polynomial for x is equal to a, then it is written as p of a. That means we have to replace the variable x by the value a so as to get the value of that polynomial for the value x is equal to a. To illustrate this, we have one example. For x is equal to 0, find the value of the polynomial x square minus 5x plus 5. So first of all, we will name the given polynomial as p of x is equal to x square minus 5x plus 5. We have to find the value of this polynomial for x is equal to 0. So we have to replace the variable x by 0. So for x is equal to 0, instead of x we should have p of 0, that is equal to x square means 0 square minus 5 into x, that is 5 into 0 plus 5. So 0 square is 0 again, minus 5 into 0, that's 5 plus 5. So 0 minus 0 plus 5, the answer will be 5. So p of 0 is equal to 5. So this is the value of the polynomial for the value x is equal to 0. Let us have another example of the same type. Here, if p of y is given to be 2y cube minus 6y square minus 5y plus 7, and we have to find p of 2. So we have to find the value of this polynomial for value 2. So firstly we'll write the given polynomial, that is p of y is equal to 2y cube minus 6y square minus 5y plus 7. Now we have to find p of 2. That means for y is equal to 2, we will have p of 2 is equal to, now in the given polynomial we have to replace y by 2, that is 2 into y cube means 2 into bracket 2 cube minus 6y square, that is 6 into 2 square minus 5y, that is 5 into 2 plus 7. Now we'll simplify this. 2 into 2 cube is 8 minus 6 into square of 2 is 4 minus 5 2s are 10 plus 7. So 2 8s are 16 minus 6 4s are 24 minus 10 plus 7. So if we simplify this, 16 minus 24 will get minus 8, minus 10 plus 7 will be minus 3. So minus 8 minus 3 we will get minus 11. So this is the value of p of 2.